Then come to definition 2. Here, suppose an is a sequence and n0 belongs to natural number and n0 is a constant. Then, if for all n such that n greater than n0, an greater than an plus 1, we say an is eventually monotonic decreasing. This means the same thing above, but we have seen monotonic decreasing and strictly monotonic decreasing, but this sequence will be start from some point. That means for above sequence and series start from 0 to and start go there. But here this sequence start from like this, it will show like this, and after that it will go. So from here we will start, right? From here it will start and show the monotonic like monotonic series, right? So here eventually monotonic decreasing, eventually strictly monotonic decreasing, and eventually monotonic increasing, eventually strictly monotonic increasing are same above, but this will start from middle of the sequences, middle or some after some part, not from very initial, right? The same thing, no need to confuse, but same thing, but here n greater than n0. So I say this is n0. So after this part we will speak about monotonic, but in here we cannot see the monotonic behavior, right? Here you can see the examples, right? And I'll come to the final section. This is the bounded sequence. So bounded sequence is if for all n, an less than k, where k is a real number constant, we say an is bounded above. Right here, this is come to convergent. So here we have a series like sequence like this, but on top of this sequence we have k. Right? Always an less than or equal to k. But if you take this value, this value, this value, any value should be less than k. So when n increases, so if you get the y value, that means this value, it should always less than k. This means this series is sequence is bounded above. Bounded above means there is a man on top of this graph. There is a man k on top of this graph. So this is the bounded above. So in other way around, so we have like this sequence. So this is bounded below. There is a man here. This sequence will not go below to this one, right? So it will reach to this one. So simply what happening? Bounded above and bounded below are convergent, right? If an both bounded above and bounded below, we say that an is bounded. So if we have a series like this, so if we have a series like this, so this is bounded below and bounded above, right? So here we have few examples. So if you get this series -1 and -1 to the power n, so what happened? This is a bounded sequence. Why? So this sequence will go like this. This will go like this. So here bounded above and bounded below. So this is 1, this is -1, right? So the same thing explained here. So as I said earlier, this is a very easy section. So but the lengthy section, but very easy. And here relationship between monotonicity and boundedness. So monotonicity, we know if the sequence getting reduced or getting increases, we say monotonicity. Boundedness is if we have a boundary on top of the sequence or on below of the sequence, it's a boundedness, right? Here the last thing, I think after that we should start the sequence series. right? Here series starts, right? Here suppose an is monotonic or eventually monotonic. So monotonic means it may be monotonic increase or monotonic decrease, or strictly monotonic increase or strictly monotonic decrease. We can, or eventually means it will start after some point, right? If an is monotonic increasing means the sequence getting increasing and bounded above, then an is converge. Right here, if you write the graph, it will come like this. What happened? An, when n increases, an also getting increase, but in some point there is a border. There is a border. So a monotonic increasing and bounded above. There is a man on top of this sequence bounded above. Then an is convergent. The second one, an is monotonic increasing or eventually monotonic and not bounded above. There is no boundary on top of this sequence. Then limit an tends to infinity. What will happen? So it will go like this. So there is no any boundary. So when n increases, so it will end up with infinity. So this is divergent. This is monotonic decreasing and bounded below. The other way around. So like this. So we have, here we have a boundary. So here again this is convergent. If we have a boundary, so in summary, if we have a boundary to the sequence, it may be monotonic increasing or monotonic decreasing. If we have boundary, it is convergent. If we don't have boundary, it is a divergent series, right? So main thing you have to know, to find the last element, that means the nth element. Only if we can find the nth element, we can say whether it is a divergent sequence or convergent sequence. So if you get this one, if you simply replace the infinity to n, what will happen? You will end up with infinity over infinity. So there is no point to this answer. So we have to find another way to calculate. So that same example showed here. So look it down and ask me if you have any questions. So that is all about sequences. Next we have to start a series. I will not start today. So I leave to you to go through again the sequence part and get the past paper questions, MCQ and the structure paper questions, and do the questions. And if you have doubt, you can put a message on group or on personal message, whatever is easiest for you.